Hello, everybody, and welcome to another episode of React Roundup. I'm your host today, Dave Ceddia, and today on the panel we have Lucas Heisch.
Hello, everybody.
And Thomas Aylott.
Hello, Internet people.
And joining us as a guest today is David Khourshid.
Hi, nice to be here.
He's maybe better known as David K. Piano on Twitter, and Dave is the author of a library called Xstate and also a bunch of really amazing code pens. To the show, David. Glad to have you.
Thank you for having me.
Hey folks, I just want to let you know quickly about Netlify. Netlify is a really cool system for hosting what are traditionally known as static sites. However, the real benefit that I've been finding is that I don't have to mess with a back end. I can just set things up. I build the website out. I've been using a system called 11DJS, and you just deploy it. And then anything that you have that you want to do, you can do on the front end. So if you want to pull in some kind of database with Firebase or something else, if you want to collect form data, Netlify provides all kinds of services that make it easy to do all that stuff. If you're trying to do serverless, they have a really, really neat serverless setup that will allow you to deploy your websites without having to deploy a backend, and it'll do some of the work for you. I just love it. So if you're looking for a way that you can actually deploy a website that only has front-end technology in it, gives you all the tools that you typically need for the back end without having to actually program the back end, then give them a try. Go check them out at netlify.com.
Could you tell us a little bit about yourself and your background?
Sure. So I've been a web developer, software engineer, however you want to call it, for the last 7 years. I currently work at Microsoft, where I've been working there for a little over 2 years. And previously, I was just jumping around startups. I started off learning PHP, but my passion has always been the more front-end side of things. So I eventually moved on to JavaScript, CSS, and just exploring that landscape and seeing what kind of damage I could do. I also play piano, hence my...
Oh, nice. That makes sense. How did you get into software development? Was it like through university or you self-taught or...
Sort of. So the interesting thing is that I actually went to college about, I think like 10, 12 years ago, or however many years ago. Can't math right now. But I studied piano performance in college. And I was always interested in computers, but I was more interested in piano, especially because, I went into university for piano. But there was a intro to music technology class where the final project of the class was you have to make your own website and you have to use this program called iWeb. It was sort of this drag and drop web editor program that was only available on Macs. And I had a PC and I really didn't want to make the trek to go to the computer lab at the university. So I thought to myself, how can I make this website myself on my computer? And so I started researching HTML, CSS, and just threw something together. And when I presented my website to the class, they were like, you should really do this as a career. So that's pretty much it.
That's funny. Sorry. So you did a piano performance as an undergraduate?
Yes.
That's funny. It's not the first person that we have as a guest that has like a music background. And I also worked as a keyboard player professionally for years before being a software developer.
Awesome.
So it's pretty amazing to see the pattern.
Yeah.
Basically anything with a keyboard.
Uh-huh. Yeah.
Just changing keyboards.
Helps with your typing skills. I mean,
There you go.
yeah.
Yeah, I can say that. My typing skills is probably like my worst part as a developer.
Yeah, I hear you're supposed to use your pinkies occasionally. Like, I type with, I guess, how British people drink tea. Right.
Yeah, that's funny. So David, I know that your code pen is amazing, and I saw a bunch of your posts about CSS and CSS animation. So is this the first, a lot of people that start with front-end programming, some people start from a more design background, doing CSS and HTML. Not other people comes more from a back-end background, starting usually with JavaScript and stuff. How would you say you started? Did you just start with the CSS side of things?
So actually, I started from the the PHP side of things. Like many other web developers who have around the same experience as me, we started just working on WordPress templates and themes and, just making one-off websites here and there and maybe working with some sort of backend, maybe in PHP or C#, .NET or, something like that. And I just got a lot more interested in the front-end landscape, but JavaScript was still pretty unfamiliar territory to me. Of course, I could make some simple stuff, and I was using jQuery for everything, but I eventually was like, number one, JavaScript is really annoying, and it was back then. So I tried to do as many things in CSS and HTML only as I could. And so you'll see that, so you'll see that in a lot of my code pens. And in fact, we have a show called The Keyframers that airs every week on Mondays.
Wait, can you spell that?
Keyframers, so keyframe.rs is actually the website, but Keyframers. It's me and Stephen Shaw, who works at CodePen, and we actually do a lot of these CodePen HTML and CSS experiments with only a tiny hint of JavaScript. That's basically where I started. I got really fed up at jQuery, as pretty much everyone did, because jQuery quickly devolves into this very complex mess of code that you have to enable or just start anew, when you have a new project. So that's where I sort of tried to develop techniques for doing everything in just CSS and HTML. But eventually I learned that, JavaScript, when, properly planned out and modeled, it could actually be it could work in harmony with the declarative nature of HTML and CSS. So I sort of approached it the backwards way. I wasn't very good at JavaScript for the first few years of my development career.
That's funny. I kind of have a similar background. As like I was doing all front end stuff. I really got into CSS as like a challenge. I hated all the JavaScript that I saw because it was just gnarly. It was poorly managed, and it's interesting seeing somebody go through this, but with modern CSS. Because like, I guess my skills have laxed. Dang.
Right, but I mean, you would be surprised how much you could do with modern CSS nowadays. All the grid hacks that we had to do back in the Bootstrap days now is built into the language and supported in all modern browsers. We have Flexbox. Our animations look nice because we have all these transform animations that we could do, and
hardware accelerated with the browser and all this stuff.
Mm-hmm.
Yeah, so looking at that, like your main like code pen that you put on your website is the Husky.
Yes.
The CSS Husky.
Yep.
Which is crazy. So how long did it take? Like how was the process? Like where did the idea come from? Like how did you come up with that? Was that like an exercise you put yourself like?
So I typically like to look at dribbles and see, can I recreate this in, of course, only HTML and CSS. And before that one, I made a lot of pens that followed that same sort of self-imposed challenge. I was in San Francisco, at work one day, and my coworker and I were, just looking through Dribble, and we saw this, really awesome Husky animation. And so she challenged me. She's like, I bet you can't do that in just HTML and CSS. And I'm like, okay, you know what? We'll see. So I went to the hotel room that night. I spent about, 2 to 3 hours just, busting it out. Because I've done similar code pens like that before, in a way, like just the same techniques of trying to make the precise CSS shapes with the code pen and also layering the HTML elements just right so that they mimic natural movements, like natural body parts or dog parts, I guess. And using Sass and HTML, I was able to make that animation. That sort of blew up. And I was surprised, like, wow, there's a lot of people sharing this. And I didn't know why. It was just like, it's just a dog, animated dog. But
it's funny. Sometimes the things that once we've demystified something for ourselves and we fully understand it, it kind of loses that mystique and it's not really impressive anymore. But for the few people who actually use stuff, make stuff, build stuff, and share it, it's so inspiring to people to kind of show this is what's possible with this technology. And that kind of inspires people to learn and to grow and to do more. So thank you for kind of inspiring the community to get out of our comfort zone and push forward.
Yeah, and I think that's important because I have to say, and I could be wrong or, people might disagree, but I feel like one of the best ways to really learn JavaScript and learn how to craft like very well organized, good modular JavaScript is to stop using it. Try to do as much as you can. Honestly, try to do as much as you can without JavaScript. When I was making the dog, and when I'm working on other complex user interfaces and animations and trying to use as little JavaScript as possible, it forces you into a way of thinking. And that way of thinking is thinking about your dynamic app in terms of states. So even that dog, like there's certain states or poses that the dog is in. And so I'm simply using keyframes to animate between those poses. And so just like that dog is animated, that's the exact same sort of philosophy that our dynamic apps work in too, where our apps can be in different states, and everything we do is simply transitioning from one state to another state.
So how would you define a state?
A state is a moment in time. And it's sort of like an abstract concept, but for example, right now I'm hungry. That's a state.
Okay.
And so that states can change, right? If I eat something, I'm no longer hungry. So that's a state transition.
Set state hunger equals.
Yeah, except I would discourage using set state, but yeah.
Yeah.
Definitely not on a human.
So is that how you think about every time you're going to solve a problem with software, you think about like which states does that problem have? How do you transition between them?
Yeah, because the funny thing is that every single developer, all right, so when I talk to developers about state machines, which is what this overall concept is, they either say one of two things. They either say, I don't know what that is that a new library or something? Or they say, yeah, I remember learning about that in college or university many, many years ago. I fell asleep in that class. It was the most boring class ever.
Yep.
But they're important. And everything we do today, like every single one of our applications and every single line of code we write is a state machine. regex is a state machine. The way your code is interpreted is a state machine. The way your computer works and the way that networks work are based on state machines. So whether you know it or not, you're using state machines every day in your programming, but the way we do it is implicit. And that becomes hard to recognize, like which states are we in our application and which events are allowed to cause a transition between different states. And that's how you get buggy and messy code. And that's how you get things like impossible states where it shouldn't be in the states. Like, for example, if you see an error message and a success message at the same time, it sounds ridiculous, but I'm sure you've run into apps where that's happened.
Yeah.
You'd be thinking, this should be impossible. Like, why is there an error and a success at the same time?
Not to talk about when it's a success, an error, and loading state.
Oh, yeah. Time. Oh, I've seen that. I've seen that plenty of times.
That's interesting. So another possible, utility of this is being kind of like React forced us to get explicit about our view, our UI. And so thinking about how can we be explicit about the states and all of the different kind of poses that our app can be in and transitions between them can not just be good for forcing us to think about it more clearly, but can be good about like onboarding new people, communicating very clearly about exactly how the thing is working instead of hoping that we both have the same kind of mental model.
Of course. So I'm sure that you all are working on complex apps nowadays, right?
Well.
Or someone, or maybe some side projects or something. Think to yourself, how easy is it for you to onboard a new developer and say, this is how our app works? How easy is it to say, like, oh, the way that the user uses this is they log in, but that login might fail. But if they log in, then it goes to this screen and it goes to that screen. You're probably imagining this right now. And if you're not using any sort of state machine solution, then you're probably thinking, okay, I'm jumping around so many different lines of code and so many different files just to get them to understand where everything is, because everything is just haphazardly wired together. And also, showing code to a developer, I don't know, if you've seen someone else's code, it's like a different toothbrush, right? You're most comfortable and familiar with your own toothbrush, and you don't really like sharing anyone else's toothbrush. Same thing goes with code, right? But if instead you show a diagram, like what designers typically call user flows, then it makes crystal clear, sense. You could instantly see, all right, we go from this state to that state when this event happens. And this is something that even non-technical people like product managers or your CTO or designers can understand.
I think it also depends on kind of people's learning styles, because some people learn best by getting, the precise step-by-step, minute by second, step-by-step instructions, and get lost when they're looking at the big picture. And like other people need to see the big picture first, because if they just get the step-by-step instructions, they're totally lost. That's me.
Mm-hmm.
Yeah, I think there's a big difference between the sort of imperative thinking, the step-by-step thing, versus the stateful, like thinking in states.
And we kind of need both in order to fully understand something.
Exactly.
Flip back and forth.
And if you think about it, like especially with regard to, state machines and how your app flow works, a states would be, of course, just specific statuses or modes in time that your app is in. And an events would transition between those states. So your imperative way of thinking of like, all right, do this, then do that, then do that, that's just a series of events.
Mm-hmm.
And so you could describe it as such. So it still fits within this whole state machine model.
Yeah. The part that I think it's one of the most interesting facts of thinking about your application as state machines, or at least a part of your application as a state machine, is that before touching code, you can, if you are describing your state machine in whatever language or platform or tool that you choose, you are able to collaborate really, really like deeply with non-developers too.
Right.
So this is, for me, this is a huge win of working with state machines.
That's
it's
a huge point.
Yeah, like designers and product people, they're looking at the thing with you, and they are like, okay, so this doesn't make sense. That transition here does not exist, or there should be a transition from this to this. If you are able to bring this state machine to your code, that means that you just collaborated with really smart people that are not developers.
Right.
So this is interesting.
It is. It's interesting, and it seems innovative. But first of all, other industries, like other areas in tech, have been doing this for decades now. And also, if you think about it, the way we develop nowadays, like just as a collective whole, I'm not saying everyone does this. Hopefully, not every developer does this, but it's sort of like asking a developer, can you build me a house? And they grab a shovel and they start digging.
That's it.
Yeah.
That's it.
Yep. And then you're like, actually, that room needs to be bigger. And they're like, no problem. I will just dig around and move things and, readjust things.
Yeah.
And you wonder why the house takes so long to build and why certain things are creepy.
Yeah. Let me show you the house. This is a wall. This is another wall. That's not the way you show a house. The wall, lots of bricks. Can you see? Like there's some bricks here, some bricks over the others.
Maybe.
Right.
I know
So for centuries, they knew that this is probably a pretty dumb way to build things. And so we have things called blueprints, where we have a blueprint, a schematic diagram, a model of how something is supposed to be built. And then we could iterate on that either using CAD software like design software, or pencil and paper or something like that. Yeah. And then once that model is finalized, then things are built. I'm always surprised to see it like just huge structures such as bridges and just other like huge buildings where I'm like, they had to plan this and get everything exactly right. Otherwise, it like highways and stuff. Otherwise, it would just fall apart.
That's it.
Yeah.
So
the checklist manifesto, because they go into that a ton in that book. Like the guy is a surgeon. He's trying to learn how to get better at teamwork in hospitals and learning from the construction industry, because their success rate is through the roof, and they're throwing buildings together. skyscrapers willy-nilly like that with, they're not falling over. Everybody's getting stuff done. Everybody's getting paid. Nobody's getting hurt. Well, relatively.
Yeah. And so that's why I think it's important that we should learn from these other industries, not just tech industries, even though there's so many things we could learn from. For example, the gaming and, game tech and automotive engineering, embedded electronics, especially.
Yeah, I was going to say all the hardware stuff. I mean, that's the difference between hardware and software. You've got to nail it the first time because it's going to cost you thousands of dollars extra if you have to recreate these circuit boards over and over again.
Yeah, sending it to the moon, maybe write in Java.
Yeah,
exactly. And so that's one of the things I talk about in my presentations is that sending the Mars rover, I think it was a $200 billion project. It was an insane amount of money, and they had one shot. The software had to work perfectly in order to, fire the boosters at the right moment and make a smooth landing. And they had to predict every single possible thing that could go wrong.
Yeah.
Right. Otherwise, it's $1 billion mistake. And we could afford as software developers to make mistakes, which is why we just start programming without really considering modeling our software properly.
We can get away with it. Nobody's holding us accountable.
Do you think it's also an effect of the waterfall versus agile mindset? Because I think that there was a big cultural shift, the waterfall is really bad because it's months of planning, and then when software gets written, it's not what we needed, so projects fail. That's why we need to do agile. That is let's create deliverable things from day one.
Yeah.
So do you think that maybe we went too far? I think that people we tend to think that after we create code, creating code and changing code is almost zero cost, but it's not. It seems to me that's what I like to say to people. It's not, I don't want to go back to 2 months of planning, but I want to have at least 2 hours of planning something.
Right.
And
so if you're working in an agile environment and you don't have, these proper planning sessions, then sure, you're going to move fast and break things, but with an emphasis on breaking things. And then you're going to have your team spending a week where the goals of the sprint are less on features and more on fixing bugs. But thankfully, your team will be wow, I was really productive this week because I fixed a lot of bugs that I created in the last few sprints.
That's it.
But that's not productive at all.
And I'm
going to say this right now. Fixing bugs is unproductive, completely unproductive. Preventing bugs, that's what's productive.
Nice. Yeah. And some things are really, really, really difficult to change. Nothing is more permanent than a bad interface.
Oh yeah.
in a company. If you just let's just do this interface this way and then we figure out how to do better in the future, then 5 other systems are consuming your interface. That's it. That's your interface. You're going to be married for months.
Yeah,
for years.
I think,
if it's a bad interface, it's gonna haunt your dreams for months and years.
Yeah.
Until you're able to deprecate things.
Prototypes are a myth, right? Whenever you start something off, you're oh, this is a throwaway, right? And then
there's no throwaway.
Someone sees it kind of works, and oh great, ship it, and then forever.
So that's why in React, especially when I program in React, focusing a lot on the state machine approach allows you to, I know this word is tossed around a lot, but it allows you to decouple the logic from your user interface. And of course, you're going to have, logic tied to user interface elements, such as when this button is clicked, then do this. But it becomes less of when this button is clicked, fire this action and do this side effect and also load this data. And it more becomes when any user interface element is interacted with, send an event. That's it. Don't do anything else, just send an event. One of my demos with Xstate was to create, of course, a to-do MVC. And so I experimented with, all right, let's do this completely using state machines. So, of course, I had that proof of concept working, and I had a to-do MVC, React, it looks like all the other ones. But what was awesome was there was someone, I forgot who it was, but they took my exact code and they ported it to Svelte. And they said, I didn't need to change a line of code in the machines. I just reused the machines. All the logic was the same, and I just rewired the user interface actions. And
that's awesome.
That's the way it should be. And so I'm thinking longer term in the future, like going further and reusing business logic in Swift or Kotlin or React's native if you want to stay with JavaScript and or other languages.
The third horseman of React. React started with we have all these problems. Let's make one thing composable, just UI. We'll figure everything else out later. And then with hooks, we got now let's get composable with side effects and all the life cycle stuff. Now that's composable too. This feels like the next level of composability is being very intentional, extracting the state machine out. Because I've seen, we've all seen kind of state done in a million different ways, but it's going after developer experience or being more intentional with this, that, the other thing. But it seems like there are too many conflated concepts that need to be extracted out and kind of dealt with separately. So we need to be intentional about dealing with those concepts separate from the other concepts.
Right. Yeah. And so it's an interesting point you made about the conflated concepts, because I think that every state management library that we have in React, especially, there's a new one coming out every week, honestly.
There's a new one.
But they're all partial state machines. Like once you learn what state machines are, you realize that they partially implement them. And so I'm not trying to push my own library. I'm just trying to say, important to think about, it in terms like when I see a counter example and I see it directly manipulating state, just add one. Immediately I start thinking of the edge cases. It's what if you want a max value? What if you want some other thing to increment the count, like you want a timer also incrementing the count? Then you have to copy and paste that code. Or, what if you want some other business logic where for example, you could only increment once every second, something like that.
Yeah, where do those rules live?
Exactly. Yeah. And so what ends up happening is they live in our event handlers all throughout our app. So some of the simplest changes that you could make to improve your app and sort of think in this more state machine mindset is look at your event handlers and say, are they doing anything extra than dispatching an event? And if they are, you might be doing too much in your event handlers.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give you full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code devchat at Sentry.io to get 2 months free on Sentry's small plan. That's code devchat at Sentry.io.
So I think we did not mention it. We're actually now talking about your library called Xstate. It's a framework agnostic library.
Yes.
It already has adapters to the most popular frameworks. And that's the way you work with it, right? You first create a JSON, which is a configuration of your state machine where you configure everything. You have a great visualizer that you can just copy and paste it there. And then you can look at and you can start playing with firing events and see what happens to the state machine. That's the part which I really think is great, because that's the part where you don't need to, you are still collaborating with whoever have domain knowledge of that product, of that business. Everybody can sit together in a computer and talk about how the system works.
What are the even more basics of where does this go? So imagine I have just a vanilla React, create React thing. I'm using, maybe I threw Redux in there because I don't know what I'm supposed to do. So I just hear, okay, there's this thing called Xstate. What would I use it for, and what would I remove from my app to replace with this? Is this directly competing with something? Is this like Redux with a different name? Like, no, it's not, but like...
Honestly, use it however you want to use it. And that's why I made sure like the state machine itself is just a transition function. It's a pure function. And so, of course, you could use that in your Redux reducers. All you do is you tell it what's the current state, what event just happened, and it spits out the next state for you. It doesn't.
So this is not competing with Redux. This is like
not necessarily
with it.
Although people have replaced Redux entirely with it, but we won't go into that. But so that the machine part, pure function. You could also have it execute effects and do all of that, and so would be using an interpreter. And so then it just becomes an event emitter. You could send it events. You could listen for state changes. That's it. And so it's really easy to integrate into any apps, and that's why adapters are actually pretty slim. So for example, I have use machine hooks for React where you could just pass the machine into use machine and you could use it just like a reducer. The only other, well, not the only, but another benefit it gives you is it actually executes side effects for you, the side effects you specify in your state machine. For Vue, people just stick it right in Vue, and they subscribe to state changes and update their data model, when state comes in, and then they have that send method so they could send events to it. And it actually feels very much like Vuex, so people are able to use it in Vue. And so there was also recently an article that I tweeted that someone wrote about how to use Xstate within an Angular application. So that's an important thing too, because since you could subscribe to a service, you could use it as an observable. And Angular wants observables, so there you go.
That's amazing. I have one question. Like, what did inspire you to look at that? Like, which other things inspired you? And what do you think, like, that is not Xstate related is doing like interesting work with state machines? Like, what languages or frameworks or whatever like inspired you in the first place?
So for the initial inspiration, it was actually one of my first jobs out of college was I was working with this medical company, and we were doing prescribing workflows for these very, very expensive specialty medication where you had to fill out forms. And I'm sure you've all had forms where it's like, show these fields if this is clicked, but if this is clicked and that's clicked, then show a different form and all this validation logic. And it became extremely tedious for us to hard code it, which is what we've been doing. So I just tried more and more to make a more declarative way. Of course, I used jQuery because I was still a junior developer to specify these in sort of like a domain-specific language. And I started researching, like, there's got to be ways to declaratively represent these workflows. And so the more I searched Google, I started learning about, people are using state machines for this. And so I started diving into the topic of state machines and then eventually state charts, which are an extension on state machines. And I'm like, this is awesome. Why aren't we using this on the web? We really, really should. And so there are actually a few interesting projects with state machines and state charts. So first of all, I'm standing on the shoulder of giants. Nothing that I've made is invented. It's all just based on research and the work of others. Some of my favorite tools are Jacob Beard is a developer who has created Scion as a project, which interprets what's called SCXML. And so it's an XML format for describing state machines. No one likes writing XML, but this actually makes it really nice and declarative. And it is a shared format which can be interpreted by many different languages. So that's at least something that's nice about XML. But he has so many tools for working with these SCXML machines. So I encourage you to look at Scion.
How do you write it?
SCION. So I guess the same as the car. There's a car called Scion.
We'll put the link in the thing.
Yeah. Also, there's statecharts.github.io, which is just a wonderful resource on state charts in general, including some references to Xstate and Scion and SCXML too. So that's what I love about SCXML. It's an interchange format, which means if you write in SCXML, it's compatible with many different interpreters in many different languages.
Did you say SCXML?
SCXML, which stands for State Chart XML. And it was originally used for interactive voice systems. So, those annoying things on the phone where it's like press 1 to
press 1 for English,
stuff like that. And it just works you through that workflow.
Press 2 to hold indefinitely, and then we'll disconnect you.
Exactly. That's a broken state machine.
Yeah.
But at least they're setting your expectations by announcing it. So that's
right. Yeah, and in different languages, there's so many other projects that are based on state charts as well. There's, I forget what it's called, like I think USC or something. It's like a C-based state chart interpreter for embedded electronics. There's Sysmic, SISMIC for Python. Even Java has some cool things. The Spring State Machine comes to mind. It's not SCXML compatible, but also if you're familiar with Qt, which is one of those, we talk about Electron a lot for desktop applications, but for people not in the JavaScript world, there is Qt, which allows you to make these interactive, highly dynamic desktop applications written in languages such as Python or C++. And those also use SCXML and state machines too to control app flow.
Yeah. What's the name of the old headless browser tester thing?
So there's Selenium.
Yeah, the other one.
Nightwatch. WebDriver, something like that.
There's one of them. Anyway, one of them's made with Qt.
Oh, okay. Yeah. No, Qt is actually used in a lot of applications.
Yeah.
Even for like inside car interfaces and stuff like that.
That's cool. So, David, also when I see some of the strong typed languages that are being like used in the front end, like Elm and Reason, I always see things that like resemble a little bit. So they have these like different states, different actions, and you have side effects depending on different actions. Are these like, is the Elm architecture a state chart or?
So it's not exactly a state chart. It does follow state machine principles too, especially and honestly, this is one thing that I feel is sorely missing from React, which makes patterns difficult. But Elm has the concept of when your app is in a current state and you send it a message, it's called. I mean, I call it events, but in Elm, I think they call it messages. It returns the next state of the app plus what it calls commands.
Yeah.
And so these commands it's a declarative representation of side effects to be executed. And in React, the pattern is simpler. It's states plus events equals next state. But there's no concept of effects. And of course, we have the use effect hook, but the use effect hook is based on which properties or which values changed, which doesn't really make sense because the only time an effect can execute is when the state's changed. And so that's why you state transitions. So
the use effect would be more parallel to the activity concept instead of the side effects, right?
Yes. And so to quickly explain, the activity concept is it's like a side effect that is only active for the states that you're in. So for example, if you have an effect where you have a loading spinner, like something's manually spinning the loading spinner, then that should only be active when you're in the loading state. So that would be an activity.
Yeah, so I remember there was a Twitter thread that you were involved. They were talking about that. Like React is really good at the React code you write is really good at defining things that happen in particular states. But it's really bad at defining things that happen when particular events happen.
Right.
Right. So that's probably like the missing. That's the part that is difficult to write with React without a library like Xstate. And that's so another interesting thing about that is that on ReasonML, the first version that they had of the Reason React before this last version that uses the hooks, they had actually an abstraction. They had like the reducer component.
Yes.
They had a good abstraction of updates. And now that they changed to use the use reducer hook, it kind of lost also, right?
Yeah, so I'm not familiar with the latest version of Reason Reacts, but I know that the previous version had something like Reason Reducer or something .update with side effects. Mm-hmm. Which makes complete sense because you're representing here's the next state and here's the effects to execute, which, use reducer, that hook doesn't let you do. It just
that's it.
The next state.
And that's why in Redux we have all these auxiliary libraries like the Thunk, the Sagas, the Redux observables. It's because it's not well baked into the React and Redux way of doing things, how side effects run. And it's interesting, like how the Elm architecture holds really well and how the state charts way of doing things, which is like side effects should be related to events. Yeah. It seems to be more like long-lived, so maybe it's a solved problem.
Yeah, it is. And that's because state machines are based on, having these side effects tied to your states. And it's what's called output in state machine language. And so this dates back to like the 1950s. But there's such things as mealy and more machines, which determine when do side effects happen, when you enter a state, when you exit a state, or in between states. That's why it was, I don't know, this is sort of my opinion, but it was a little bit silly for Redux to say, we'll manage the state changes, but the side effects, we don't want to impose an opinion. That's up to whoever. You could use Thunk or Observable, but there is no opinion. There's a well-defined mathematical way of doing it. And so that's why I actually like Redux Saga for that reason, is because they have the declarative notion of side effects. And so that makes it also a lot easier to test.
Yeah, it's really interesting how like none of this stuff is really new problems. I think a lot of it's kind of relegated to the academic stuff. Like we were talking earlier, I think my first exposure to state machines was in college, and I never really touched them after that. Like I never wrote any code for them. It was just drawing circles on paper and being like, when this happens, move to, transition to another state.
Right.
And yeah, stuff has been around for years and years, but sort of hasn't. I think there's sort of there's a barrier to taking that stuff, that abstract academic type stuff, and translating it into like, okay, how do I use this to like build my to-do app or whatever?
Right. Well, I mean, that's how functional programming was for a long time, and other academic concepts.
Yeah. I remember like flow-based programming. I got super into that years back. There's a library called NoFlow.
Ah, yes.
Which is really cool.
Super visual.
Yeah, super visual. And it's based on some work that was done, I think, all the way back in the 70s. And they even like brought that guy in and to explain to them, his thinking process behind it. And it's kind of, instead of thinking about state as a machine, it was thinking about the logic of the network as
data flow.
It's kind of hard to summarize it.
It's still related concepts though, because you can think of that data flow as state machines communicating with each other, passing messages. And then you sort of get into the actor model, which is also a very old concept. But that's
But in general, it seems like we need more kind of education in the industry. Like I started just on my own. I was a designer. I was a print designer. And then I just kind of self-taught over the years. Like I taught myself the concept of version control. I went out and like, I'm sick of these zips. Like, let me see if there's some other concept. I taught myself.
But
testing all this stuff. But
Thomas, I don't think it's about education, because like a lot of people who learned about state machines like on university, they were like, that is boring class. I never thought. Right. I think we need like killer apps being created with killer libraries, and the last UI I created in the last in my last job, I used a website called Sketch Systems. I don't know if you heard about that, David. It's like it's a really easy way to create and collaborate, creating like simple state charts. And when I started like creating that, it was interesting. I brought the designer and to the product manager, and they were like, "Oh, it's like it's a revelation." It's like, "Oh my God, there is a place where we can actually collaborate." And then I remember, I don't know exactly what was, but like the product designer asked like, okay, so I want to add like a confirmation if these things happen. You start typing and you see that there were like 3 new screens created.
Yeah.
And then you're like, okay, so do you see like the effects of this decision you made? Like this is going to create like 3 more screens with like 5 different messages. So this is going to make this is going to affect the estimates. Like we need to be careful with those new stuff. And this is going to generate more work for the designer, more work for me. Are you sure you want that? So like when
That's
you
brilliant.
work, like it's about, if you bring to the table a good solution to a real problem, I think it just starts getting used. I cannot think about creating UIs today without at least.
I guess that goes into like accountability and like standards and what do we tolerate in the industry? Like if somebody shows us, hey, here's this new project, do we tolerate it not having any unit tests? If you look at something that has no unit tests, you're like, let's bail. It's just finally we've grown accustomed to, we expect a little bit more. We have higher standards. It feels like we need to kind of up our standards a little bit more of like, it's clear that you built this awesome thing. I love it. It's great. But, your state management is very implicit. You need to, extract that out. Just like demanding a little bit more, but in a positive way of encouraging people to grow instead of us just be like, seems good, ship it.
Yeah. Why? Because, that costs money, right? That costs companies money. Developers are not cheap. But if you think about it, we spend a lot of our time, depending on how complex the product is, we spend a lot of our time doing one of two things. Either writing new features, which even if a feature seems simple, like add a button there, you're like, I have to change so many things in so many different screens, or fixing bugs. And so those two things, I would say, take the majority of our time. But those two things, with proper planning, can be drastically reduced in time, which means you save the company money, you save yourself some time, and you could do bigger and better things.
Yeah, I guess partly it's how do we get good metrics around this stuff so we don't get fired for not fixing a bunch of bugs because there weren't any bugs to fix in the first place. Like, that guy fixed all these bugs. Well, yeah, he caused all those bugs.
Exactly, and hopefully you don't get paid by the bug because, yeah, that'd be terrible.
And we're just exterminators. We're not really programmers at that point.
Yeah, exactly.
I'd love to hear more about the visualizing tool itself. Like, have you used that professionally? Has it been a useful tool for communicating with people, or is it just like a fun toy?
Oh, yeah, no. Even at Microsoft, like in a couple of the projects that I've been working on, I communicate with the people on my team also working on the same project using the visualizer. Right now, it's just a way where you could copy and paste your machine code. The exact same machine code that you have in your app, like from Xstate, you copy and paste and you put it there. Or you could even, speaking of sketch systems, you could copy and paste. Actually, you don't need, there's a button for exporting to Xstate JSON, funny enough, in sketch systems. But anyway, I'm actually in the middle of working on an updated version of the visualizer. And some of the big updates are, it's going to be, of course, there's going to be updated visuals. It's going to be more visually nice, and the arrows are going to be better and stuff like that. But also, it's going to give you the ability to save your visualizations, your machines, and share them with anyone. And that way, you could just share a link, and they'll be able to play around with it, maybe fork it and edit it themselves as well.
That'll be awesome.
Yeah.
Yeah. Yeah, it very much reminds me of the NoFlow stuff.
Yeah.
And Flow Hub.
Mm-hmm.
Except it seems super focused on just the logic, not on the actual implementation of the logic.
Right. And so that's what state machines and state charts do too, is they push implementation details to the edge. And I always love how, a lot of developers say, like, visual programming is not the future. I'm just fine with code. And then they spend 2 or 3 hours fixing a bug caused by one typo that they made.
Yeah.
So.
Yeah, it seems like we're getting more and more kind of diversity that's clustering around our genetics. Some people are genetically more visual thinkers, and some people are more genetically like audio kinesthetic thinkers. But we haven't quite gotten physical interactability with our code yet. So it is more of a struggle for those people. But finally, we're getting better tools for us visual people.
Yeah. And I'm a very visual person myself. So I like to see what everything's doing at either a higher level or a lower level without having to digest the code in my head, because the place where the code is most understood is whoever wrote it, not the rest of your developers. But if you have a visual representation, now everyone has a better understanding and you have less cognitive load on understanding how your app actually works.
So much easier to share the knowledge in a visual form.
Yeah.
And it gives you like a prop to talk through things. Like you can just point and say, okay, we're talking about this concept now. So it kind of keeps everybody on the same page. I like that.
Not only can you point, you could simulate as well. So, just create simulations of how your app is supposed to work. If we run these events in series, then this is the resulting state. And, your framework is just a view layer on top of that.
Yeah, that's exciting. Yeah, I got to play with this thing.
Yeah, I'll definitely let you know when the new visualizer is out.
Yeah, give me alpha access. I promise to give you lots of QA for free.
Awesome.
Awesome.
This episode is brought to you by Triplebyte. Applying to programming jobs sucks. You have to put the right keywords in your resume. You spend hours and hours on the phone screens and take-home projects, and that's assuming the company even responds to your application. Well, if you're a software engineer, Triplebyte can help. They work with over 400 top tech companies, from big names like Dropbox and Adobe to exciting startups. You do one brief online interview with them, and if you do well, you go straight to final interviews with the company on their platform. It's like the common app for software developers. Triplebyte does not look at your resume or where you went to school. All they care about is if you can code. I've helped dozens of software developers with various credentials get jobs, and this looks like a terrific way for you to get in and get interviewed and get a job without a lot of the hassle and overhead. You can go check them out at triplebyte.com/react. That's triplebyte.com, byte as in 8 bits. As a special offer for listeners of this show, if you take a job through Triplebyte, they'll offer you a $1,000 signing bonus.
Well, we're coming up on the hour here. You guys want to move to picks?
Sure.
I guess I can go first. So I've mentioned this one on the podcast before, but I'm sort of going through this book again. It's called Atomic Habits by James Clear.
Yes.
And it's a good book. It's all about lots of different strategies for how to build habits in your life, how to stick with them, and how to get back on track when you inevitably falter. So that's definitely check out Atomic Habits. And the other one is Bullet Journal, which has been around a while now, and it's pretty much a to-do list. So if you like to-do lists, but you would prefer like a tangible to-do list in a notebook versus a bunch of apps or something, Bullet Journal is a cool way to do that. It's kind of a little more systemic than just a plain old to-do list. Thomas?
Cool. So one thing mentioned earlier is the checklist manifesto. I've owned it for months, so I'm finally actually reading it and underlining as I go. And it's been very interesting for kind of a lot of the same topics that we're talking about here. And as far as like James Clear goes, I guess my second pick is I just started a YouTube channel all about diving into advanced objective personality, where I'm learning kind of an obscure, kind of bleeding edge psychological research thing. And this week I just typed James Clear. He's a kind of an introverted / extroverted INTJ type.
Interesting.
Yeah.
Cool.
And you can find that somewhere.
Yeah, we'll put a link in the show notes.
Yeah.
David, got any picks?
Book picks.
Yeah, books, websites, tools.
Well,
whatever.
one book that I mention in a lot of my talks is Ian Horrocks' Constructing the User Interface with State Charts. And the interesting about this book is it was written in 1998. And so you can imagine, this is back in the days of Windows 98 and stuff. And he even has an example where he sort of rips apart the Windows calculator and says, like, program, there are quite a few bugs in it. And then he reprograms it with state charts. But it is a really interesting book where it actually has a lot of relevance to this day. All the concepts in it can easily be applied to modern development, and there's so many use cases and things like that. Now, the thing I'll warn about is try to find it at your local library because it's out of print. Online, if you look on Amazon, the prices range from like $200 to $600 because it's out of print. So
wow.
Look at your local library first. Yeah.
Awesome. Must be a great book.
Digitize it.
Yeah.
Google, where are you at?
Cool. Well, that about wraps it up. So thanks, David, for joining us today.
Thank you for having me.
Yeah, it's been great. So where can people find you online?
David K. Piano everywhere. GitHub, Twitter, LinkedIn. I guess I never go on there. Yeah.
Awesome. All right. Well, this has been great.
Yeah, awesome.
Yeah, thank you.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.